Okay, so our goal today is to learn about quadratic functions and their graphs, and also talk about maximization and minimization problems. So quadratic functions that we're going to talk about today have this shape, or they have this shape. Okay, those shapes are called parabolas. We'll talk about them officially soon, but they're called parabolas. This point is it the smallest or the largest point right here? It's the smallest. Good. This is the smallest point. That will be called our minimum, but it's also what's called the vertex. This point here is called your what? Maximum. Very good. Okay, so whenever we get to talking about maximization and minimization problems, you'll have this picture in your mind. These 2 points in both shapes is called your vertex. That's called your vertex. Okay? That's called the vertex. And there's a special formula for it. You'll use that whenever you have these applications of maximization and minimization problems. You'll use it to help you. Okay? So let's start out with the definition. A quadratic function, f in the variable x, also known as a second degree polynomial function, is any function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. So a quadratic function can be written in this form, f of x equals ax squared plus bx plus c, where again a, b, and c are real numbers and a is not equal to 0. Okay? A fact: the graph of any quadratic function is a roughly U-shaped curve known as a parabola. That's what we were talking about whenever we first introduced it here. So let's look at a couple of examples. We want to graph the functions below. One way you can graph them, if you need to remember how to do that roughly, you can do your XY chart, but remember y and f of x are the same. So you can take values of x. We can take 3 to be -1, 0, and 1. If you want to find the corresponding f of x value, that means you need to take -1, substitute it in, take 0, substitute it in, and see what you get, and substitute 1 in to see what you get. So f of -1 is equal to -1 quantity squared, which is what? 1. Very good. So that means we have -1, 1. So 1 point on our graph, you go over to -1, go up 1. So go over to -1, go up 1. That's 1 point. Now when x is 0, what do you get? 0. Good, because 0 squared is 0. So you have 0, 0 is another point. And then when x is 1, what do you get? Good, you get 1. So 1, 1 is a point. So go to the right 1 from 0, then go up 1. That's another point. And then you can sketch your graph. That's the graph of f of x equals x squared. Okay? In part B, let's graph f of x equals the quantity x minus 6 squared. Notice that here we have a quantity on the inside, which is x minus 6, and we're squaring it. The fact that we're squaring it means that whatever this shape, whenever we're looking for the shape of the graph will also be a parabola. Because we know that it's a positive 1 in front of the x squared term whenever we expand it, we know it's going to be facing up. Okay, so this x minus 6 on the inside, this x minus 6 right here, says we need to take that parabola and shift it to the right 6. So that's 6. And then we sketch our graph.
Why do you move it to the right if it's negative?
That's a good question. So the question was, why do we move it to the right? Because this is negative. We're moving it to the right. Let's graph a few points. Let's plot a few points to see why. So the question again was, why is it moving to the right instead of the left? Because when you see a negative, you tend to think, hey, we need to move to the left. But because it's on the inside here, it's a little different. Okay, so let's choose a few values. So if you have 0, well, let's choose -1. Let's choose 0. Let's choose 5. And let's choose 7. And let's find the corresponding y values. Okay? So f of -1 is equal to the quantity, so we put parentheses, -1 minus 6 squared. That's equal to -7 quantity squared. -7 quantity squared is 49. It's 49. Okay? So -149 is a point on the graph. Okay? F of 0 is equal to 0, the quantity 0 minus 6 squared. That's equal to the quantity -6 squared, which is what? 36. Good. So that tells us whenever we want to figure out what our y-intercept is, it's going to cross the graph at wherever 36 is. So just for the sake of doing this, let's make this 36. And then at -1, you want 49, somewhere up there. So really, your graph would be a little bit like that. Okay? And going up, so if we're looking at the parabola extended, it's going to look like that. Okay? So whenever we have x is 5, f of 5 is equal to the quantity 5 minus 6 squared. 5 minus 6 is? Good. So that's the quantity -1 squared, which is what? 1. Good. So that tells us that 5, 1 is a point on the graph. So that's 5, 1. And then whenever we have 7, notice that f of 7 is equal to the quantity 7 minus 6 squared. 7 minus 6 is 1. 1 squared is? 1 squared is? Good. So 7, 1 is a point on the graph as well. So notice that using our points that we got, we see the shape of the graph is a bigger parabola, but it's moved to the right. So whenever you see an x minus here, that means you move to the right. But if you see an x plus 6 squared, quantity squared, what do you think is going to happen? It's going to go to the left. Good. So just for extra information now, so an extra one. If we have the quantity x plus 6 squared, then a sketch of that graph would be, what's the shape of it? A parabola, good, facing up, but instead of moving to the right from 0, is now going to move to the left. Very good. And then your vertex is at -6, 0. So again, this is, you move to the left -6 because now you can rewrite this as x minus a -6 quantity squared. All right, so now let's talk about the vertex of a quadratic function. First, we're going to define it, and we're going to look at some examples, and after we go through those examples, we're going to talk about the vertex formula, okay? Now, the graph of the function g of x equals a times the quantity x minus h squared plus k, where a, h, and k are real numbers and a is not equal to 0, is a parabola whose vertex is hk. So this you want to remember. This is a standard form for the vertex form of a quadratic function. The vertex is hk. So right now you should be remembering you have some standard forms that we've talked about in the past that pop up. You have a standard form of a circle, right, which is a quantity x minus h squared plus the quantity y minus k squared equals r squared. That's the standard form for a circle. You have the standard form of a line. Here now you have the vertex form. You have the vertex form of a quadratic function. This is something you need to remember, okay? Now, facts, very important. If the absolute value of a is greater than 1, so if you zoom in on this a, if the absolute value of a is greater than 1, then the parabola is narrower than f of x equals x squared. So remember on our previous page, we graphed f of x equals x squared, right? Are you with me? Okay. This was f of x equals x squared. The vertex was at the origin, which was 0, 0. So part 1 says if the absolute value of a is greater than 1, then the parabola is narrower than f of x equals x squared. Narrower means that it looks something like this, right? So what's happening is, imagine yourself grabbing the two arms of the black parabola and pulling it up, stretching it. If you stretch it, it becomes narrower, right? That's what's happening in part 1, okay? So this stretches your parabola, making it skinnier, okay? If the absolute value of a is between 0 and 1, so in other words, if it's a fraction that's less than 1 or a decimal less than 1, then what's happening here, I'll use green, then the parabola is broader than f of x equals x squared. So what's happening is, you imagine taking your arms here and pressing them down, which is going to make this graph wider, right? It's going to make it wider because you're pressing that down. Okay? Now, if a is greater than 0, so if a is positive, another way of saying a is greater than 0, if a is positive, that you want to make note of. Another way of saying this, a is positive. If a is positive, then the parabola opens upward. If a is negative, then the parabola opens downward. So it can look like that. Okay? Now, we know all about the shapes. Now the thing is, parabolas may not necessarily be given, or the function may not be given in this form, this vertex form. You may have to put it in vertex form. which will remind you of a concept we learned before, which is completing the square. Okay, so first let's look at an example that's already in this form and sketch the graph and find its vertex and its x-intercepts. Okay, I'll minimize that so you can see everything here. Part A, for example 2, we want to graph the following quadratic functions, locate the vertex and x-intercepts if there are any. So here we have g of x is equal to negative. This is an understood negative what here? 1. Very good. That's an understood negative 1. So if you need to write that there, do that if it makes you happy. So this is negative 1 times the quantity x plus 2 squared minus 1. This is already in this standard format, okay, for the vertex form. G of x equals a times the quantity x minus h squared plus k. It says we want to graph the following quadratic function. So I have a question for you. Is this parabola going to face upward or downward?
Downward.
Downward. Excellent. Why?
It's negative 1.
Because of that negative 1. You went to fact 4 and you said if a is negative, then the parabola opens downward. That's absolutely correct. So we know it's going to open downward. We know the shape. We just don't know where it's located right now, but we know it's going to look like that. So now we have to find the vertex. To find your vertex, remember, you have to have x minus h, but this is x plus 2. So we want to rewrite this to get negative times the quantity x minus, because subtracting a negative gives you your plus. So it's negative 1 times the quantity x minus a negative 2 squared minus 1. And here we can automatically identify that our h is negative 2 and our k is what? Negative 1. So our vertex is negative 2 comma negative 1. So that means when our graph from 0, we go to the left negative 2, and then we go down to negative 1, and we graph that point. We know the shape of the parabola is facing downward, right? So at some point it's going to cross the y-axis. Does this have any x-intercepts? No, absolutely correct. No x-intercepts. So now let's look at our next example. This one is a little bit different. Here we have f of x equals x squared plus 2x plus 4. And if we remember our vertex form, recall that our vertex form is a times x, the quantity x minus h squared plus k. And so our vertex here would be h comma k. But when we look at f of x, is it already in vertex form? No, absolutely correct. It's not. So that means we have to do a little bit of work to put it in this form so we can identify the vertex. Now we're going to have to remember completing the square. Completing the square comes back into play here. I'll remind you as we go through the example. So the first thing we're going to do, we're going to just put the x terms in parentheses. So the x squared plus the 2x, we're going to put that in parentheses, and then we're going to add the 4. We didn't change the equation. We just put parentheses around x squared and 2x. So now I'm going to use blue for an aside telling you what we're going to do in our next step. We're going to complete the square on the x squared and 2x terms. On the x squared and 2x terms. Now what does that mean? Completing the square means, again, we take the coefficient of x. You take the coefficient of x, which is 2. Then we divide that by 2. So this is our 2. We take that, we divide it by 2. Dividing it by 2, we get what? 2 over 2 is 1. Good. So we took the coefficient of x. And divided by 2. We got 1. The next step is that you take that 1 and you square it. 1 squared is what? 1. Good. So we square 1 and we got 1. So what we're going to do now is we're going to write this as x squared plus your 2x. Here we're going to write plus 1, right? That's completing the square. I'll use yellow here. This is the 1. Okay? But we have to finish our equation. We have to add 4. But whenever we put this plus 1 here, we change the equation from this. So to make this equation the same, to make this line the same as this line, if we add 1, we also have to do what? Add to the 4 or what? So think of a seesaw for a second. If both of y'all want to float in the air on a seesaw, it has to be balanced, right? Same idea mathematically. If you want to, if your level space is 0, if you add 1, you also have to do what? Subtract 1, because you got to remain balanced, right? So here, because you added 1, you have to subtract 1. You have to subtract 1. That's that whole seesaw effect. We got to remain balanced. So if you add 1, you have to subtract 1. So your equation won't change. So we're going to subtract 1 from right there. So that means that this is now x plus 1 quantity squared plus, what's 4 minus 1? 3. Good. So a quick recap. Our original function, quadratic function, was not in vertex form. We want to put it in vertex form. So you have x squared plus 2x plus 4. We put the x squared and the 2x plus the 2x in parentheses, add the 4. And then we have to complete the square for our variable x squared and 2x. So we take the coefficient of x, which is 2. Divide by 2, we get 1. Then you take 1, you square it, you get 1. So you add 1, but you also have to subtract 1 because our equation, our function needs to be the same as at this step as it was in this. So now we rewrite it. We have it now in vertex form. But this is plus 1. So can you tell me what your vertex is going to be? Say it loud. Tell me exactly what it's going to be. Yes, the first one will be negative, but what is it specifically? Very good. Your vertex is -1, 3. Because if you want to rewrite it, this would be x minus -1 quantity squared plus 3. So you identified your -1 from there, and then your 3 there. So in this space over here where it has vertex, we're going to write -1, 3. So whenever you're sketching your graph, you go over to the left from 0, -1, then you go up 3, that's your vertex. Is this parabola facing up or down? Up, very good, because this number is positive. Your A out here is a +1. So we already know it's going to look like that. Are there any x-intercepts? No. So no x-intercepts. Okay, so this is our graph. Vertex -1, 3. It's facing upward because that's a positive out here. So we know it will never cross the x-axis, so no x-intercepts. Now let's look at another one. We have k of x equals 2x squared minus 4x. K of x equals 2x squared minus 4x. Is this already in vertex form? No, it's not. So we're going to have to do the same thing, approach it the same way that we did before. But this time, whenever we look at these two terms, we're going to complete the square in x squared and x, right? But notice they have a 2 in common. So we're going to write this as 2 times the quantity x squared minus 2x. Are we good so far? Okay, so now what we're going to do is complete the square. Do you want me to write on the side like we did before? Yes? Okay. So we're going to complete the square. And this one is a little different, and let me tell you why. We're still going to complete the square, but when we add a number, we have to make sure we multiply that number by 2, because that 2 is on the outside. Before, we just had a 1 here. Okay, but now we have a 2, so we have to be a little bit careful. So we're going to complete the square on the x squared and 2x terms, -2x terms. So we take the coefficient of x, which is what? Yes, -2. I'll use the same colors as before. We take -2 and we do what with it? Yes, divide by 2. -2 divided by 2 is what? Very good, -1. Now what are we going to do with the -1? Very good, square it. -1 squared is what? 1. Good. So now we have this 1 here. So just to write out, we took the coefficient of x and divided it by 2. We got -1. And then we squared -1 and we got 1. So that means here we have 2 times the quantity x squared minus 2x, and what do we have to put here? Very good, plus 1 here. But careful, what we're really putting in here is 2 times 1. We're really putting 2 times 1 in. So before, where we subtracted 1, here we should be subtracting what? Very good. We should be subtracting 2.
Wait, why are you subtracting?
You want to explain why we're subtracting 2?
Because within the parentheses,
Very good. Very good. So why are we subtracting 2? That was a great explanation. Because in parentheses you have this 1, but you're really multiplying everything in parentheses by 2. Because you're multiplying everything by 2, that means you're really putting in a plus 2 here. And because you want to remain balanced, you have to subtract 2. So that's why you're subtracting 2.
So we were adding a 2 in the parentheses, we would subtract by 4.
Yes, you would. So if you had a plus 2 here, and you would be putting in a positive 4, so you would have to subtract 4. Yes. So pay close attention to what number you have here, because whenever you complete the square and put a number here, you have to multiply those, and if it's negative, you have to, if it's negative, you have to add. If it's a positive, you have to subtract whatever you put in there. Okay? Great questions. So now, to rewrite this in vertex form, you get 2 times the quantity, x, minus 1, quantity squared, minus 2. What's your vertex? Very good. 1, negative 2. Your vertex is 1, negative 2. Okay, so we can go ahead and start to sketch a graph. That's what we've done in the past. Let's do it now. So go over to the right 1 from 0. Go down 2. That's negative 1, 2. Now, looking at the vertex form, is that parabola going to face up and down or down? Up. So notice here that it's going to face up, so we better have what? X-intercepts. So I'm going to erase those arms right now and know that we need to figure out what our x-intercepts are, because we already know that the graph is going to face upwards. So we'll be more precise with our x-intercepts. To find your x-intercept, you set your y equal to 0, or your k of x, in this case, equal to 0, and then you solve. So that means 0 is equal to 2x squared minus 4x. No surprise, we're going back to our original function, and we're going to set our original function equal to 0, and we're going to solve for x, because we need to find our x-intercepts. Those two terms have a 2x in common, factored out. So that's 2x times the quantity x minus what? Good, x minus 2. You have a product equal to 0, so that means either 2x is going to equal 0 or x minus 2 equals 0. If 2x equals 0, you divide both sides by 2 to get x equals 0. Or you add 2 to both sides here to get x equals what?
2.
Good. So your x-intercepts are 0 and 2. So your x-intercepts on your graph, you plot 0, and then you go over to 2 from 1 on the x-axis, and use these 3 points to sketch a curve or your parabola. Okay, so there's an easier way to do this. You have to know both ways, okay? You have to know both ways. This one is a lot easier. This is the vertex formula. Know it, okay? You can have the same instructions, but you can use the vertex formula instead. Here, I'm just going to, after we talk about the vertex formula, we're going to go through examples where you can locate the vertex by using the vertex formula instead of putting your quadratic function in vertex form. Okay, so there are 2 different approaches. We just talked about, given a quadratic function, sketching its graph by putting the function in vertex form. Now we're going to talk about being able to locate the vertex by actually using the vertex formula instead of putting your quadratic function in vertex form. Okay, so you need to know this. Star it, flag it. You need to know this. Okay, vertex formula. Given a quadratic function, f of x equals ax squared plus bx plus c, the graph is a parabola with vertex given by negative b over 2a, comma, f of negative b over 2a. So you identify b, you identify a, and then negative b over 2a will give you your x coordinate. And whenever you find out what this is, when you plug it into your function, plug that, whatever you got here for your x coordinate, into your function. Whatever you get after you substitute that in or plug it in, that will be your y coordinate. This is the vertex formula. This is another way of finding your vertex. That's not a highlighter. There you go. But your function has to be in that format. Okay? So, let's do an example. We want to find the vertex of each of the following using the vertex formula. We want to find the vertex of each of the following using the vertex formula. So, in part A, we have p of x equals negative x squared plus 2x minus 5. For us, what is A?
-1.
Good. What's B?
2.
And what is C?
-1.
Good. So now, to find our x coordinate, we have to do negative b over 2a. That's negative 2 over 2 times what?
-1.
Good. Times negative 1. That gives us negative 2 over negative 2, which is 1. So to identify our vertex, we can already go ahead and start writing it out. Our x coordinate is 1. To find our y coordinate, what do? Plug 1 in. Very good. So f of negative b over 2a, we already found negative b over 2a to be 1. Not f. Our function is what?
P.
Very good. Let's stick with our function. Good. So p of negative b over 2a is equal to p of 1. So you have negative. Notice that that 1 is in parentheses, not the negative with it. The negative is hanging out on the outside. So you have negative 1 times the quantity 1 squared plus 2 times 1 minus 5. 1 squared is 1, so this is negative 1 because that negative is hanging out on the outside. That means we have to square the 1 first and multiply it by the negative. Plus 2 times 1 is 2 minus 5. Negative 1 minus 5 is negative 6. Negative 6 plus 2 is what?
-4.
Good. So our vertex is 1, negative 4. That's our vertex. Our vertex is 1, negative 4. Take a minute and do part B. Take a minute and do part B. Part B, you have h of x equals x squared plus 6x plus 7. Find the vertex of h of x using the vertex formula. So this opportunity is worth 5 points, extra credit. Towards exam 1 for those who are in class today. Go ahead.
All right, what's up, gangy? All right, look. So you're gonna start off the problem with. Oh, you can't hear me? All right, look. So you're going to start off the problem with your vertex formula, but first you want to write out your problem. X squared 6x plus 7. You know?
What's
And
missing?
The h of x, But listen.
Y'all better
So
help
then-
him out. This is for 5 points now.
Oh, you missed usually.
Oh, you're right.
No, you gotta help guide.
Okay.
Okay, I got to help
Okay,
God.
you're learning
You're missing
experience.
the equal sign. Yeah.
Okay. And then what I like to do is I like to write it out, what your a and all that is. So your a is 1 because you don't have a negative in front of the x squared.
You did what now?
You don't have a negative in front of the x
I thought
squared.
you said you do.
Uh-uh.
Okay.
You don't have a negative in front of the x squared, so you write that out. And then your b, I can't write, my fault.
Your B look like 6.
Hold on, my fault. I don't know how to erase, but your b is 6. I ain't lie, I'm up here shaking.
You explain it well. Keep going. That's
So
the
now-
eraser right there.
Okay. Let me get y'all right.
Make that B clear.
How I get off that?
That's the pencil.
Uh,
Okay.
yeah.
Y'all don't keep going. Encouragement. He came. Y'all hype him up and
All right, look. So now,
Explain.
so now you're going to write out, the negative b. I know it look like a 6, but bear with me, guys. Yeah. So then, over 2a. So now you have everything you need. You have your b, and you already have your a. So when you put that over it, I can't write the smallest, but it's we're going to get right.
Pinch it like you do your screen, and it'll make it smaller.
Hey, that's tight. I ain't gonna lie. I need an iPad. So then, that'll be equals negative 6 over. Oh, you took the paper, didn't you?
It's over 2 times 1.
Did they explain it to you? Go.
I was just making sure we was right. You know what I'm saying?
No, they helping you. Listen to them.
What we say, team?
2 times 1.
2 times 1. That's what I like to hear. Right? So then, if you do your simple distributive properties, you know what I'm saying? You get negative 6 over, straighten that out, over 2, which will give you negative 3. That's bad. Hold on, guys. All right, 3. Right? So when you get that negative 3, you're going to bring that down into your equation because now that is your x. So now, dang, why I switched to that? Trying to get me right. So then, you're going to come down, and it'll be h of negative 3 equals negative 3 squared
And I like how you put that in parentheses. That's good. Keep going.
plus 6
Times a negative 3.
times a negative 3
And then
plus
plus 7.
7. So, when you go to your, distributive properties,
Are you distributing?
not distributing, but, I like to say distributing because it keep my mind.
You're doing what?
Square.
You're
Squaring. I
Use proper terms. Keep going.
real.
You're squaring.
So then, a negative 3 times a negative 3 equals a 9. Hold on, guys. There we go. And then you bring it down. You get the 6 times a negative 3, and a positive times a negative equals a negative. So, plus 18,
Negative 18.
negative 18. Oops. And then you're going to add a 7. And when you add all of that together,
Negative 2.
you get a negative 2. So then that will end your equation because you already have your x, which is -3. So your vertex would equal -3, -2. Make sure you add the parentheses, otherwise you'll be incorrect, gang.
All right. Perfect. Y'all should applaud. Good job. We're going to keep going. So good job. Now, that's right, you can applaud. That's good. And you did great. Good collaboration, you all. Great presentation. Okay, so we've been talking about these quadratic functions that are parabolas. That's the shape of the graph. And so now we're going to go back and provide the mathematical explanation for what we talked about at the beginning when we introduced this, which is if you have a parabola facing downward, you pick up a maximum. So note that that is your vertex, right? So that would be your maximum. And here, if your parabola is facing upward, you're going to pick up a what? Minimum. Very good. And again, all of this is coming from your vertex. And you have a beautiful way of finding your vertex or locating your vertex. The vertex formula. So even though you're about to see applications, it's going back to the vertex formula. The difference is in your application, you may not be given a quadratic function. You got to figure out what it is. That's the only difference. That's the most challenging part of these applications. Okay, so let's start out with example 4. Here, it says, among all rectangles that have a perimeter of 20, find the dimensions of the one whose area is the largest. Okay, so among all rectangles, if you're highly visual, what should you draw? A rectangle. Draw a rectangle. Whose perimeter is 20. What's the perimeter of a rectangle? If we're talking about the perimeter, what do we have to do? It's 20, yes. But what do we do with the sides? Add them, right? These two sides are the same. You want to call that L or W? Call this W. We'll call the other one L. I just tend to write my L's in cursive. So the perimeter, if you're adding all the sides, L plus L is 2L. W plus W is 2W. So the perimeter is 2L plus 2W. That's your perimeter, right? We're told that our perimeter is what? 20. Good. So that's equal to 20. That we know. It says, find the dimensions of the rectangle, whose area is the largest. How do we find the area? A for area. How do we find the area of a rectangle? Very good. It's length times width. The only thing that's keeping us from doing this initially is that we have these two variables here. But we can go over here and solve for one of the variables. Which one do you want to solve for? The L? We'll solve for L. Notice that the 2L and the 2W have what in common? 2. Let's factor that out just so we can deal with smaller numbers. So you have 2 times the quantity L plus W equals 20. You can now divide both sides by 2. Notice that these 2's will cancel, leaving you with L plus W equals what? 10. Good. You said you wanted to solve for L. So you go ahead and do what now? Subtract the W. Good. So you have L is equal to 10 minus W. Now let's go back and recap, see why we did that, because we're not done yet. Among all rectangles that have a perimeter of 20, That's what this information, where this came from. Find the dimensions of the one whose area is the largest. So we know A is equal to L times W. We need A to be in terms of one variable, but we know our perimeter gave us that L is equal to 10 minus W. We can now substitute 10 minus W in for L here, and our area will be in terms of one variable. So we get A is in terms of W. Not we're multiplying by W, but A is in terms of W. That's equal to the quantity 10 minus W times W. That's equal to, if you distribute your W, 10W minus W squared. Well, lo and behold, you have a quadratic function now, right? That's perfect, because if we are looking for the one whose area is the largest, what do you expect to pick up? A maximum or a minimum? A maximum. And if we're very good. And if we're picking up a maximum, you expect the graph to be facing downward, right? Well, look, your parabola is negative W squared plus 10W. That negative here means your parabola is facing down. So you're going to pick up a maximum. So everything that we know to be true is already true. So now we just need to actually find out what we get. So notice that we just need to find out what the first coordinate is. We don't need to find out what we get when we substitute that in, because that will just give us the maximum area. We just want to find the dimensions of the one whose area is the largest. So we go back. We have our negative B over 2A. We're using our vertex formula because we want to find the maximum. What's A? Good. A is negative 1. And what's B? 10. Good. So negative B over 2A is negative 10 over 2 times negative 1. That's equal to negative 10 over negative 2. Negative 10 over negative 2 is what? 5. Good. So that means W, that means our width is equal to 5. Our goal is to find the dimensions of the one whose area is the largest. We found our width. Our width is 5. Now what do we need to find? The length. How do we find the length? Plug it in for W here. Very good. Plug it in for W here. So to find L, we get 10 minus 5. 10 minus 5 is 5. Good. So the width and length are or is 5. Both your width and your length is 5. Your length and your width is 5. All right, one more example. This one's not that bad. The total cost of producing a type of small car is given by C of X equals 9,000 minus 135X plus 0.045X squared, where X is the number of cars produced. How many cars should be produced to incur minimum cost? What do we do here? Can't hear you. Is it B over 2A? Negative B over 2A? Which one?
Yeah, negative.
Negative B over 2A. Good. You're doing negative B over 2A. What does what do you expect if you're looking for a minimum cost? What do you expect your function to look like graphically? A parabola facing up. Excellent. Go figure, our parabola is facing up. Right? So what do here? We rearrange our terms, right? To put it in descending power or order with x squared first. So c of x is equal to 0.045 x squared. What's next? Talk loud. Good. Plus 9,000. And we rearranged it so we can have our quadratic function in the standard form that we're used to. And then what do?
A, B, and C.
Identify A, B, and C. What's A?
0.045.
Good. And what's B?
Negative 135.
Negative 135. Do we need C?
No.
No, we don't need C. So let's just go with this. So negative B over 2A. Again, you can use your calculators if you wish. Okay? Negative B over 2A is the same thing as negative times negative 135 over 2A. 2 times 0.045. 2 times, well, negative times negative 135 is 135. 2 times 0.045 is what? 0.09. Good. And 135 divided by 0.09 is?
1,500.
1,500. Excellent. So, how many cars should be produced to incur minimum cost?
1,500.
1,500 cars. It's a lot. But we got to produce 1,500 cars to incur minimum cost. That's it. That's section 4.3.